Hi guys, welcome once again to EasyLearn online tutorial platform. If you're just watching our video for the first time, I'd like you to subscribe to our YouTube channel. You can also like our Facebook page. We also have an Instagram page. I will put the link to all those pages in the description box or in the comment section box so you can follow us so that you get notified of anytime we drop our useful contents. Today on chemistry class, we are considering a very important topic, the kinetic theory of gas and gas laws. We've started this topic and this is the part 2. Alright, so today we'll be considering the gas laws, Boyle's law, Charles' law, and the general gas equation. What are the gas laws? What's the essence of gas laws? They explain the relationship between the characteristics properties of a gas. In our previous lesson, we told you the three most important variables, characteristics properties of a gas, which are the volume, the pressure, and the temperature. These gas laws tells us the relationship between these properties, how they depend on each other, and the gas laws include Boyle's laws, Charles' laws, Avogadro's laws, Gay-Lussac's law of combining volume, Dalton's law of partial pressure, Graham's law of diffusion. Yes, what does the Boyle's law state? We are starting with the Boyle's law. The Boyle's law postulates that the volume of a given mass of gas is inversely proportional to its pressure. Inversely proportionality means if the volume increases, the pressure decreases. In other words, whatever happens to the volume, the opposite of that thing happens to the pressure. Again, if the volume decreases, what happens to the pressure? It increases. Opposites. So we can represent that expression, volume inversely proportional to pressure, right, at constant temperature. This is very important. The temperature must be constant, right? So we can represent this so from this expression we can just deduce a Boyle's law formula and what does the V1 represent? It represents the initial volume of the gas. V2 represents the final volume. P1, that is the final pressure, and P2 is the final pressure. So this is the formula we use for Boyle's law. Anytime you have a question that is asking for the relationship between the volume and the pressure of a gas, this is the suitable formula you use. Now let's have an example on that. Okay, before we have the example, this is the graph that explains Boyle's law. You can see from the graph that as the pressure is increasing, what happens to the volume? It's decreasing. So the pressure is inversely proportional to the volume. This is also a graph that symbolizes the Boyle's law. So either of the graph is correct and they represent Boyle's law. Now let's move to the example. We have a question here on Boyle's law. It says 375 centimeter cube of a gas has a pressure of 770 millimeter mercury. Find its volume if the pressure is reduced to 750 millimeter mercury. You have to know that the unit of pressure is millimeter mercury, and we also have other units. Try to go through our previous lesson on kinetic theory of gas. You understand what I'm saying? Alright, so from this question we are given the initial volume of the gas, 375 centimeter cube. You're also given the initial pressure, 770 millimeter mercury. Find its volume. That is the final volume. We're looking for the final volume. If the pressure is changed to 750 mercury, just recall your formula on Boyle's law. Right? So substitute your values. Your V1 is 325. Your P1 is 770. Your V2 is unknown. Your P2 is divide both sides by 750, and you have your answer as 85 centimeter cube. So option B is right. Right. We have another question here, and it's actually a past question. It's a UTME question. A UTME question on Boyle's law. The pressure on 100 centimeter cube of oxygen gas at 35 degrees Celsius is 750 millimeter mercury. What will be the volume of the gas if the pressure is increased to 1000 millimeter mercury without changing the temperature? Now, if you look carefully at this question, the temperature is constant. The temperature is not changed. Okay, so you don't have anything to do with the temperature since it's constant. It is obeying Boyle's law. So you go on and use your Boyle's law formula. Recall Boyle's law's formula: V1P equals V2P2. So what's your V1? Your V1, that's your initial volume. It is 100 centimeter cube. And your P1, you're asked for your V2, and your pressure is being increased to 1000 millimeter mercury. So feel free to pause the video and try to do it on your own. And this is what you have. Substitute your value in the equation. You have 100 times 750 equals your V2 times 1000. Of course, you divide both sides by 1000. Your V2 would be 75 centimeter cube. Option C is right. Now I think we are done with Boyle's law. We can move to Charles' law now. Charles' law states that the volume of a given mass of gas is directly proportional to its temperature, provided that the pressure remains constant. Right? This law tells us the relationship between the volume and temperature of a gas at constant pressure. Right? So the volume decreases as the temperature decreases. You can see direct proportionality. That means the volume depends on the temperature. Whatever happens to the volume happens to the temperature. If it increases, the temperature also increases. If the volume decreases, the temperature also decreases. So that is that about Charles' law. We can represent that also. V is directly proportional to T. Of course, at constant P. Constant P. Charles' law is not obeyed if the temperature is not constant. So whenever you are stating Charles' law, don't forget this important clause. Right? So when we express this further, we have this. If you try to make K the circular formula by dividing both sides by K, V equals K equals V over T. Then from this expression, we deduce the Charles' law's formula that says V1 over T1 equals V2 over T2. V1 is the initial volume. you know is your final. The same T1 is initial temperature, and T2 is your final temperature. This is your Charles Law's graph, a straight line, a linear graph, establishing the fact that volume is directly proportional to temperature at constant pressure. You can see that represented on that graph. Now this is a question on Charles Law. At 17 degrees Celsius, a sample of hydrogen gas occupies 125 centimeter cube. What will be the volume at 100 degrees Celsius if the pressure remains constant? Now this is a question. It has to do with the volume and temperature of a gas, so you already know you are applying the Charles Law's formula. Recall that V1 over T1 equals V2 over T2. Right, so the initial temperature is 17 degrees Celsius. I told you, whenever you are given a temperature in degrees Celsius, you have to convert it to Kelvin. And how do you do that? Just add 273. 273 plus 17 would give us 217. 273 plus that will give us 290. This is 290 Kelvin, and we are given the initial volume. Initial volume is 125 centimeter cube. What will be the volume at 100 degrees Celsius? So our final temperature is 100 degrees Celsius, also converted to Kelvin. So plus 273, this will be 373 Kelvin. Okay, so what will be the volume? So we are looking for the volume. We are using this formula. Right, substitute your value. You have 125 over 290 equals V2 over 370. You cross multiply, your V2 equals 125 times 373 over 290, and your right answer is 161 centimeter cube. Yes, this should be the right answer. There must be a mistake somewhere. This is the right answer. Alright, now to the general gas equation. Now you've seen that the Boyle's law shows the relationship between volume and pressure. Charles' law shows the relationship between volume and temperature. Now, the relationship between the three variables, volume, pressure, and temperature, is shown by the general gas equation. So in other words, general gas equation is a combination of the Charles and the Boyle's law, and we can represent that. The general gas equation, this is the general gas equation. It shows the relationship between the three variables of gas. Yes, V1 P1 over T1 equals V2 P2 over T2. In this equation, you can see the Boyle's law formula right here, and also you can see the Charles' law formula. I don't know if you get what I'm trying to point out here. So this is the Charles' law formula, and this is the Boyle's law formula. General gas equation is a combination of those two laws. Let's look at an example on this. Right, this is a UTME question, UTME past question. If a gas occupies a container of volume 146 centimeter at 18 degrees Celsius at 0.971 atmosphere, its volume in centimeter cube at STP, of course you know what STP is, standard temperature and pressure. If you don't know that, kindly go over a last topic, the part 1 of this video. So we write out our given parameters. We are given the volume, the V1 of this. So V1 is 1 to 6 centimeter cube. Also T1 is 18 degrees Celsius converted to Kelvin. You know how to do that. Add 273, and if you do that, you have 291 Kelvin. Also, we are given the initial pressure 0.971 atmosphere. Don't forget that at STP, the chosen value for temperature is 273 Kelvin or 0 degrees Celsius, and that the chosen value for pressure is 760 millimeter mercury. This is also equivalent to 1 atmosphere. Keep that in mind because you're going to need it in this question. Now, the question says its volume, the volume of this gas, the final volume of this gas in centimeter cube at STP. That means the final temperature is the standard temperature, which is 273 Kelvin. We are using the value in Kelvin because our temperature here, the initial temperature is also in Kelvin. What will be the final pressure? The standard pressure. Now our pressure here is in atmosphere, so you are going to use the value of the standard pressure in atmosphere, which is 1 atmosphere. Go ahead and write your general gas equation. Substitute your values. Your V2 is unknown. That is what you're looking for. Is the P2, 1 atmosphere, divided by your V2 will now be equals to, if you calculate all this together, you should have if you simplify all this together, you have the answer is 133. 133 centimeter cubes. This is not answer. This is another question on general gas equation. It's a UTME question. 200 centimeter cube of a gas at 25 degrees Celsius exerts a pressure of 700 millimeter mercury. Calculate its pressure if its volume increases to 350 centimeter cube at 75 degrees Celsius. Of course, so we have our initial volume, 200 centimeter cube. We have the initial temperature, 25 degrees Celsius. Convert this to Kelvin to be 298 Kelvin. Alright, so we have our initial pressure, 700 millimeter mercury. We asked to calculate the final pressure if its volume is increased to 50 centimeter cube and the temperature is also increased to 70 degrees Celsius. 75 degrees Celsius in Kelvin is 348 Kelvin. Using the general gas equation, so this will be 8 over, sorry, your T2 is 348. If you simplify all that, your P2 as 7467.11 millimeter mercury. That makes option B the right. So these are examples on general gas equation, and that's where we're going to end it for this video. Thank you very much for watching this video. We can go over once again to get the full understanding of these concepts. So we are done with Boyce, Charles, and general gas equation. Stay tuned. We are coming again for the next part of this video, where we're going to discuss ideal gas equation and Avogadro's law. Till then, I'd like you to subscribe, hit the subscribe button, support us by subscribing to our YouTube channel for free. Click on the notification button to get notified when we drop a subsequent video. You can also ask questions on these lessons. Ask questions in the comment section. I will make time to answer all the questions. So we are done for today. Thank you for watching. God bless.